Welcome back to Different Perspectives. This is part 2 of our deep dive into how experts from various fields approach the same problem. Remember in our last episode we talked about how valuable it can be to look at a problem from multiple angles? Well, today we're going to see that play out in a fascinating way. We're taking on time series forecasting, a tool used everywhere from predicting stock prices to understanding weather patterns. And even in your work, wouldn't it be incredible to know what's coming next? That's the power of forecasting. The study we're diving into today throws a curveball. It compares those tried and true statistical methods, the ones that have been the backbone of forecasting for years, with a new wave of machine learning algorithms. Get ready to see how these two very different perspectives unlock some serious forecasting power. Now, I know you're probably already familiar with the classic approaches, statistical models like ARIMA and exponential smoothing. They've been the reliable workhorses, consistently identifying linear trends and seasonal patterns. But what's really interesting is that even with all the hype around machine learning, these traditional methods still hold their own in many scenarios. They're like the foundation of a well-built house, straightforward, robust, and easy to understand. ARIMA, for example, excels at spotting those linear relationships in data. It's perfect for data sets with clear trends and those patterns that repeat over time. Think of it as the detective who can connect the dots and predict the next move. Then we have exponential smoothing, a bit more flexible and adaptable. It's like a chameleon, able to adjust to different types of time series data by capturing both seasonality and trends. So even though it's a more traditional method, it's definitely not stuck in the past. These statistical models have been favored for their clarity and robustness. They give us a solid understanding of what's driving the patterns in our data, and the results are easy to interpret. But hold on, because things are about to get a whole lot more interesting. The world of forecasting is rapidly evolving, and that's where machine learning enters the scene. Machine learning models like random forest, LightGBM, and XGBoost take a completely different approach. Instead of relying on predefined assumptions about trends and seasonality, they dive headfirst into the data, learning complex, nonlinear relationships. It's like they have a sixth sense, uncovering hidden patterns that traditional models might miss. Imagine these algorithms as explorers venturing into uncharted territory, mapping out the intricate details of the data landscape. And as you might have guessed, the study put both these approaches, the seasoned veterans and the daring newcomers, to the test. They chose the classic air passengers dataset, which tracks monthly airline passenger numbers. It's like a time series forecasting playground, perfect for comparing different techniques because it has those clear trends and seasonality we talked about. The study used both statistical and machine learning models to predict future passenger numbers based on this data. And what they found was, well, pretty eye-opening. Machine learning models, particularly random forest, consistently outperformed the traditional methods when it came to prediction accuracy. In fact, random forest achieved a remarkable 30% improvement in accuracy. It's not just a slight edge, it's a significant leap forward. Now, before you think, okay, time to ditch those old school methods, remember what we talked about earlier, different perspectives. This study doesn't mean traditional models are obsolete. They still have tremendous value, especially when we need a model that's easy to understand and explain. But this research does highlight the incredible power of machine learning to capture those subtle, intricate patterns and achieve a whole new level of accuracy. And this is where it gets really exciting. This study suggests that a hybrid approach, blending the strengths of both statistical and machine learning models, could be the ultimate forecasting solution. And that's what we're going to explore next. So stick with us, because you're about to discover how to take your forecasting skills to the next level. All right, let's unpack these machine learning models that really stole the show in this study. First up, we have random forest, which is like having a whole team of forecasting experts working together. Imagine a forest made up of decision trees, each analyzing the data from a slightly different perspective. Random forest takes the predictions from all these individual trees and combines them, averaging out any biases and giving us a super accurate and robust prediction. It's kind of like getting multiple opinions before making a big decision. And the study found that this approach was incredibly effective at handling the complexities of real-world data, like the air passengers dataset we talked about. But random forest wasn't the only machine learning star in this show. We also have LightGBM and XGBoost, two powerful algorithms that use a technique called boosting. Think of boosting like coaching a team, where each member focuses on improving the areas where the previous member struggled. These algorithms start with a simple model and then refine it over and over, zeroing in on those data points that were initially misclassified. This process continues until the model becomes a forecasting powerhouse, capable of picking up on even the subtlest patterns in the data. The study found that both LightGBM and XGBoost performed exceptionally well, showing us just how much potential machine learning has for revolutionizing time series forecasting. Now I know what you might be thinking. If these machine learning models are so great, why even bother with the traditional statistical models anymore? Well, here's the thing. It's not about choosing one over the other. It's about understanding the strengths and limitations of each approach and using them strategically. Remember, traditional models like ARIMA are still incredibly valuable, especially when we need a model that's easy to interpret and explain to others. They provide that clear, step-by-step logic that makes it easy to see how the model arrived at its predictions. But when you're dealing with complex data and need the highest possible level of accuracy, machine learning can really shine. And here's where things get really interesting. This study suggests that the real magic happens when we combine both approaches, a hybrid strategy. Imagine using ARIMA to establish that solid foundation, capturing the basic trends and seasonal patterns. Then we bring in the machine learning models to fine-tune those predictions, adding those nuanced insights that only they can uncover. It's like building a house where the traditional methods provide the strong structure, and the machine learning techniques add the intricate details and finishes. This hybrid approach can lead to even more robust and accurate forecasts, giving us the best of both worlds. Now, as we explore these different approaches, it's important to remember that there are some challenges and considerations that come into play, especially when it comes to using these powerful machine learning models. One of the biggest challenges is interpretability. Traditional statistical models like ARIMA are pretty straightforward. You can easily see how each parameter influences the forecast, making it clear why the model is predicting what it is. But with machine learning, especially those ensemble methods like random forest, it can be a bit of a black box. We can see the predictions, but it's not always obvious how the model arrived at those predictions. And this can be a real hurdle, especially when you need to explain your reasoning to others. Think about it. You're presenting your forecast to your team and they ask, okay, but why does the model predict a spike in sales next quarter? Okay. If you can't clearly articulate the factors driving that prediction, it can be hard to get everyone on board. Another thing to consider is the amount of data you have available. Machine learning models are data hungry. They need a lot of information to train effectively and reach their full potential. If you're working with limited data, traditional statistical models might be the better option. They're more efficient at learning from smaller data sets and can still provide valuable insights. And let's not forget about computational complexity. Those powerful machine learning algorithms can require a lot of computing power, which might be a limitation for some organizations. Traditional statistical models, on the other hand, are generally less demanding and can run on less sophisticated hardware. So when you're deciding between statistical and machine learning models, it's essential to consider these factors: interpretability, the amount of data you have, and the computational resources you have access to. It's all about finding the right balance between accuracy, interpretability, and practicality. But here's the good news. The field of time series forecasting is constantly evolving, and there are exciting new tools and techniques emerging all the time. One of the most exciting developments is the rise of deep learning. It's a subset of machine learning that's inspired by the structure of the human brain. Deep learning models like long short-term memory, LSTM networks, are especially good at dealing with time series data. They can capture those long-term dependencies, the connections between events that are far apart in time. Those are the connections traditional models often struggle with. Imagine trying to predict stock prices. A deep learning model could consider not just recent price movements, but also things like historical trends, news events, and even social media sentiment. All those factors can have an impact on future prices. And then there's automated machine learning. We call it AutoML for short. It's like having your own personal data scientist. AutoML can automatically find the best model for your data. It can even tune its parameters and engineer new features. AutoML is making the power of machine learning accessible to a wider audience. Even people without a lot of technical expertise can use it. So you can see the world of time series forecasting is bursting with possibilities. Whether you choose to stick with the tried and true statistical methods or dive into the power of machine learning, the most important thing is to stay curious, keep exploring, and always be open to new ideas. Let's take a minute to bring it all together. What have we learned from this deep dive into time series forecasting? We've seen that understanding both the elegance of traditional statistical models and the raw power of machine learning can be the key to unlocking truly effective forecasting. Remember those recommendations from the study we discussed. They're like a roadmap for successful forecasting in this exciting, ever-evolving landscape. The first tip: embrace the hybrid approach. Combining statistical models like ARIMA with machine learning techniques like random forest or XGBoost can give you forecasts that are not only accurate but also robust. It's about using the best of both worlds. Think of it like this. ARIMA is like the solid foundation of a house, and machine learning techniques come in to add the architectural details and finishes. The result, a forecast that can stand the test of time. Next up, feature engineering. Never underestimate how powerful it can be to carefully craft the information you feed into your machine learning models. It's kind of like preparing ingredients for a gourmet meal. The better the ingredients, the more delicious the result. In machine learning, features are those ingredients. Things like lag features, rolling averages, and external factors can make your model perform significantly better. And speaking of boosting performance, don't forget about hyperparameter tuning. It's like fine-tuning a musical instrument to get that perfect sound. Machine learning models have these knobs and dials called hyperparameters. They control how the model behaves. By carefully adjusting those hyperparameters, you can make your model even better at learning from the data and making accurate predictions. But the most important thing to remember is to choose the right tool for the job. Sometimes a straightforward statistical model will get the job done. Other times you'll need the big guns of machine learning to tackle those complex forecasting challenges. It all comes down to the specific problem you're facing, the type of data you have, and the level of accuracy and interpretability you need. So whether you're predicting customer demand, optimizing inventory, or assessing financial risk, think about how these different forecasting perspectives can help you make better decisions in a world where knowing what's coming next can give you a real edge.
Having the right forecasting tools can make all the difference. So keep exploring, keep learning, and keep challenging those assumptions. That's how we break through boundaries and unlock the full potential of time series forecasting. And that wraps up another deep dive. I hope you've enjoyed exploring the fascinating world of time series forecasting. Until next time, keep those minds curious and those perspectives open.